Hi everybody, in this video I'm going through the solutions to our second diagnostic test for specialist maths. For these first couple of questions we're using these vectors, vector u and vector v. For this first one we've got u minus 2v. Now most of you got it right, but a few didn't, and the ones who didn't get it right got it wrong because they didn't set out their work very sensibly. So I just write them in column notation, u minus 2 lots of v. And then what's that going to equal? So let's just minus 4 minus 2 times 5 is 10, and minus 1 minus, well, what is this one? 2 times 8 is 16. Now what's that going to give? What do we have here? Minus minus is a positive. Minus 4 plus 10 is 6. Minus 1 minus 16 is minus 17. As you can see for that one, it's only worth 1 mark, which means I don't need to see any working. I only care about the answer, but you just need to make sure that you don't make silly mistakes with it. This second one is a dot product question. We've got u dot v, and again, a couple of you got it wrong just because you made errors with the negatives. So what do we do here? We write it like this, and I think a couple of you also forgot what the dot product is. How do we work out the dot product? We say that times that, minus 4 times minus 5 is positive 20, and it's plus this times this. Minus 1 times 8 is minus 8. And 20 plus minus 8, 20 minus 8 is 12. Again, a couple of people mucked it up going from there to there. Again, it's 1 mark. You don't need to show any working to get full marks for that. Okay, after the angle between these two vectors, how do we do that? Well, we're going to use our dot product formula. We've got a dot b is the magnitude of a by the magnitude of b by the cosine of the angle in between. Instead of a dot b, we've got u dot v, and we know what u dot v is from the last question, and that's 12. That equals the magnitude of a. Well, the magnitude of u, in our case here, u is minus 4 minus 1. How do I find the magnitude of it? It's the square root of that squared plus that squared. The square root of 16 plus 1 is 17, root 17. And magnitude of b is going to be the square root of negative 5 squared. That's 25 plus 64. That's square root of 89 times the cosine of the angle in between. Rearranging here, cos of theta is going to equal 12 over square root of 17 times 89, like that. And then I just use the inverse cos. I go inverse cos of that equals, and that will give me theta equals 72 degrees or thereabouts. Next question is to write v in polar form. Now vector v is minus 5, 8. Now it is, this is a question that's fine to just type that in your calculator. So on your black calculator, you can just go shift polar and then negative 5, 8, and that will give you the answer of 9.43, 122 degrees. Now you need to put those in brackets like that. Now remember that this one here is the magnitude of vector v, magnitude of v, and this one here is its angle. Now if we didn't do it that way, how would we do it? Well, the magnitude of v is going to be the square root of negative 5 squared plus 8 squared. So some of you wrote that magnitude as a square root of 89, and that is fine. Next one, we're after the angle there. Well, let's just draw a little picture. If I've got negative 5 here, that's negative 5 there, and I've got 8 up, here is our vector there. So we could look for this angle here first up. We could do an inverse tan of 8 over 5, and that's going to give me 57.99 degrees, let's say 58 degrees. Now remember that the angle that I'm looking for though is this angle here. So it's going to be 180, take away 58, which gives us 122 degrees there for that one. I'm happy for you to just do that either way, but we need to be getting it right. Some people gave us this angle here of 58 degrees, and that's not correct. Okay, so in terms of marking for this one, it's 2 marks. It's 1 mark for the magnitude, 1 mark for the angle. Find v hat, the unit vector in the direction of v. Well, remember all that a unit vector is a vector that's got the same direction, but a magnitude just of 1. So all I'm going to do is divide that by its magnitude. Divide it by root 89. And there's a few different ways I'll accept that. I would accept 1, I would accept that. That's fine, just like that. I'd also accept 1 over, what was it, 9.43, lots of -5, 8. You could multiply that through and get me -0.53i plus 0.85j. Anything like that is going to be fine. Just 1 mark for that. Find the value of x if -8i x is our vector, that we want it to be parallel to vector u. And vector u was -4, -1, like that. Now, what do parallel vectors have? This was the worst done question on this page. Parallel vectors have the same angle, okay? So what we're looking at, parallel vectors, if you think about them as being from the origin to wherever, they've got the same angle. So that actually means that they're just multiples of each other. Watch what I'm going to do here. What do I have to do to go from -4 to -8? What am I doing there? I'm timesing by 2. So what do I have to do from -1 to x? All I've got to do is times by 2. What is -1 times 2? It's -2. So x is equal to -2. Parallel vectors are multiples of each other. So in this case, I found what I was multiplying the i's by, and then I multiply the j's by the same thing. Next one here, not parallel this time, we've got perpendicular. Okay, so -8x is perpendicular to vector u. Well, vector u is -4, -1. Now, I hope that by this stage, as soon as you see that word perpendicular, you are saying that the dot product is equal to 0. So I'm going to find the dot product of these. How do we do that? That times that, plus that times that. 32 minus x equals 0. Well, x there is equal to 32. Okay, let's look at those last two again. Parallel vectors are multiples of each other. Perpendicular vectors, the dot product is 0. That one there was just 1 mark, and plenty of people got no marks for that one. And this one was 2 marks. I awarded 1 mark for that understanding there, and another mark for the answer. Okay, question 2. A glider, P, is travelling due north at 60 kilometres per hour, and another glider, Q, is travelling northwest at 40 kilometres per hour. Find the velocity of P relative to Q. This is a relative velocity question, and we're going to use our formula. So what do we have? The velocity of A relative to Earth, remember this one, equals the velocity of A relative to B plus velocity of B relative to Earth. Now, instead of A and B, I'm going to change those to P and Q. So I'm going to say P, that can be A there, and Q can be B. Okay, so what I'm doing here, velocity of P relative to Earth is P relative to Q plus Q relative to Earth. Okay, and what am I after? That is the bit that I'm after. Okay, so I'm just going to call that, maybe that can be x, y. That's what I'm looking for. Okay, velocity of P relative to Earth. Well, what's P doing? P is going due north at 60 kilometres per hour. Okay, well, what's that in terms of i's and j's? Well, we've got 0 i's and 60 j's. It's positive because it's going up. There we go. What is Q relative to Earth? Well, Q is travelling northwest. That is that one there. at 40 kilometers per hour. Now, let's work out what we need to put this into component form. Now, I could do this myself, but I'm just going to use my calculator. What is that angle going to be? Well, if we're to go northwest, that's halfway between north and west. So that's 45 degrees there. This one here is going to be 90 plus 45 is 135 degrees. So I'm really just looking for, in component form, 40 is the magnitude, 135 degrees is the angle. And that there is going to give me, what do we have? 28, negative 28.28, and then 28.28 there. Now, a lot of people just had both 28s and didn't have that negative there. So we need to have that negative there, and it makes sense that it's negative because this distance here, we're going backwards on that I value, aren't we? Now, all I need to do here is to solve this now. So I'm just going to move this over this side. So it's going to be 0 plus 28.28. It's going to give us 28.28. And then 60 minus 28.28 will give us 31.72. And that is what our velocity of P relative to Q is. Now, I don't want it in component form like that. I would like that back in polar form so I can have how many kilometers per hour and at what angle. Now, that I'm just going to put that into my calculator to do that, and that comes to 42.5, and the units there is kilometers per hour, and the angle that it gives me is 48.28 degrees. Now, this is not my final answer. I want to get an angle, gave me a question in north, south, east, and west. I want to give it back an answer like that. So this angle here that I've got is the angle with the positive x-axis, where 48 degrees here. Now, in north, southeast land, I could say that that is east, 48.28 degrees north. That's not a really common way of doing it. Mostly I want this little angle in here, which is going to be 90 minus 48.28, which will be 41.72 degrees. So I could say that's, should put a 0, 04, and let's round it to 42 degrees true. With bearings, they like to have 3 digits there. I'm not sure why. So you just put a 0 in front. Or you could say it's north, you know, what is it, 41.72 degrees east. Do what you like, but make sure we don't just give this one here. We want to give something that is kind of more north-south sort of language. Okay, question 3. This one was not really very well done at all. We're looking the shortest distance between this point here and this line. So the line that joins the origin with negative 5,8 and this point over here, negative 4,1. We've talked about this in class, but the shortest distance between a point and a line will always be perpendicular to the line. So it's going to be this one that comes up here, such that that there is a right angle. Now, how are we going to find that distance there? Well, the first thing we're going to do is try and work out what that vector is. How I'm going to do it, I'm going to use vector projections. Firstly, I'm going to create myself this little vector here that goes from 0 to negative 4, negative 1. Okay, I'm going to call that vector there that I just drew, I'm going to call that one there vector A. And this one here is vector B. Now, what I'm going to do next is a vector projection. I'm going to project vector A onto vector B. If I project vector A on vector B, I'm going to get this little bit here, aren't I? And then I can do that green bit plus the black bit plus the green bit will give me the purple bit. So I can kind of work it round like that. So we've got a vector projection A onto B. Now notice that I put this one down here as A and the other one as B, just so I can just use my numbers, my normal formula as it stands. Okay, vector projection A onto B equals A dot B hat by b hat. Okay, so we have A, which is -4, -1, dot b hat. Well, b is -5, 8, and then we're going to multiply that by 1 over root 89 to make it a unit vector there. And then we're going to multiply that by b hat, which is -5, 8, multiplied by 1 over root 89. Okay, so that's going to give us a dot b 20 minus 8 is going to give us 12 over root 89 by 1 over root 89 by -5, 8, which will give us 12 over 89, -5, 8, like that. Now I can change that just into kind of normal numbers. -0.67, 1.08. Now here, a couple of you did weird stuff and you multiplied the 12 by -5 and the 8 by 18. No. It is 12 over 89 times that and 12 over 89 times that. Okay, the next step that we're going to do is to recognize that there is this vector here, that green one. So I'm going to say, what do we have? If we want to go, we're after that purple one. So I'm going to say that the black vector plus the purple vector will get me the green vector. Is that true? Because I'm going from here, there, to get to the end of the green one. Okay, so I can just pop that in an equation. Of course, you could use the fractions and everything for this. And let's say the purple one is going to be xy. And the black one, what did we say? -4, -1. Oops. And that's plus. Okay, so all I need to do to get our purple vector here is move that one over the other side. And I can easily do that. -0.67 plus 4 gives me 3.33, and 1.08 plus 1 will give me 2.08. So that is that vector, gives that purple vector there. It's 3.33, 2.08. Now that is can you see its direction actually there is going that way. Now some of you will have done it and you'll have a negative there and a negative there and it will be going the other way, and that's fine too. It really doesn't matter. What we need to do next, we're after the shortest distance. Okay, so we're after the distance of that line, the length of that line. So all I'm after now is the magnitude of that vector. So in the magnitude of that, so it's the square root of that squared plus that squared. And that gives me 3.93. We're not told if it's centimetres or metres or kilometres, units, 3.93 units. So this one was worth 4 marks and I awarded 2 marks for that vector projection. Another mark for working out this vector here, the purple one, and another mark for finding the distance. This next one was fairly well done, but I've got some concerns about the way that it was set out on the page. So most of you managed to come up with the right answer, but your working was not enough to get you all of the marks, and especially won't be on the exam. First thing we're going to do here, we've got 30 degrees, that's 90 degrees. I'm going to put that angle there in as 60 degrees. Now this is 12 kilograms weight. You can either work in kilograms weight or you can work in newtons. If we worked in newtons, it's a 12 kilogram weight, so multiplied by 9.8, that's a force of 117.6 newtons that way. Next thing I'm going to do is redraw it, flipping my axes. So then I'm going to have that force coming down here of 117.6 newtons. And if that's 60 degrees, what is all of that? It's 180 plus 60. So that one is going to be 240 degrees. So we can just use our calculator there. to work out what that is. And that vector there is negative 58.8i and negative 101.8j. Okay, next thing we need to do is put in this vector coming up there. So I'm going to put that one over here, and that's coming up at an angle of 20 degrees to the plane. Now, I don't know the magnitude of that. That vector there has magnitude of f. I'm going to say that as a vector is f cos 20, that's the I component, and f sine 20 is the j component. Now, I'm wanting to work out what that is, and I know that this that this particle is kept at rest. That means that our forces balance out, and this one here that's going that way, the component of this is going to be the same as the one that comes that way. So the I value of this one has to balance with the I component of that one. Now, so by balance with, what we actually mean is that those two values add up to give us 0. So we have negative 58.8 plus f cos 20 is equal to 0. Now, some of you went straight to moving that round to the other side and said f cos 20 is equal to 58.8, okay? So some of you, though, said that f cos 20 equals negative 58.8. No, and that's not true. The fact is that this one and this one add to give 0. So we can say the negative of that one is equal to that one. Okay, from there, all we're going to do is divide both sides by cos 20. We put that in our calculator like that, and it will give us the force is 62.57 newtons. Now, some of you did that in kilogram weight, in which case it came to just that amount, 62.57 divided by 9.8, which is 6.38, and that's fine as well. But if you have the answer of 6.38, then you need to have the right units. The force of 6.38 kilogram weight. Okay, next question. Two particles A and B start moving at the same time. Particle A starts at negative 3,1, particle B starts at negative 1, negative 5. Now, I'm going to start here by writing something about their positions. I'm going to write the position of A equals and the position of B equals. Okay, I know that position A, the particle A starts at negative 13.1, so I'm going to put that there. Remember our formula? We said its position is equal to its starting point plus t lots of its velocity. So let's write that down. Position equals the starting point plus t lots of its velocity vector. So I've got their positions. Let's put that in straight away. Negative 1, negative 5. Plus, okay, the velocity of particle B is I plus 2j. So it's t lots of 1, 2, like that. The two particles collide after 6 seconds. Determine the velocity of particle A. Okay, we don't know what the velocity of particle A is. I'm going to say the velocity of particle A is equal to xy, something like that. So I can put that into my formula there. Now, I know that they collide after 6 seconds. What that means is that when time equals 6, their I components are the same and their J components are the same because they are in the same place. Position A is equal to position B when time equals 6. Now, it might be a good idea to actually write that down so that I can see what you're thinking. Position A equals position B when time equals 6, like that. Then we're going to write it. Negative 13.1 plus 6 lots of xy equals this, 6 lots of this. Now after this, all I can do is I'm going to simplify both sides. Negative 13 plus 6x, 1 plus 6y. Negative 1 plus 6, negative 5 plus 12. Now, in order for their positions to be the same, that there has to equal that, and that there has to equal that. And I've got two equations to solve here. I've got negative 13 plus 6x equals negative 1 plus 6, that's 5. And I can solve that. 6x is 18, which makes 18 divided by 6, x3. Next one I've got over here, 1 plus 6y equals negative 5 plus 12, that's the same as 12 minus 5. 12 minus 5, which is 7. Now I've got 6y equals 7, and I've got this 1. 7 minus 1, which is 6, which gives us y equals 1. So the velocity, make sure I'm writing it down properly. The velocity of A is 3, 1, or we could write it as 3i plus j. Okay. Now, it's asked us for the velocity, but that is not all. Determine the velocity of particle A and the point at which they collide. Some people left out that part. Now, where do they collide? Well, they collide at time equals 6. So all I need to do now is put time equals 6 into one of my position equations. And I'm going to put it into that one there because it's already pretty much complete. So position at time equals 6 is going to be negative 1, negative 5, plus 6 lots of 1, 2. That's going to be negative 1 plus 6, negative 5 plus 6, 2 is 12. That's going to make 5, 7. So the position is 5i plus 7j. And that is that question. For that, I awarded, again for that one, that was 4 marks. I think I awarded a mark, 1 mark for coming up with that, 2 marks for equating them and solving for velocity, and then another mark for getting the position. Okay, final question. Now, this was overall not done really well, even though we had done it in class a few times and I'd sent it out on the homework. The main problem was that your logic was not secure on the whole. Prove that the diagonals of a parallelogram meet at right angles if and only if the parallelogram is a rhombus. First thing we're going to do is draw a parallelogram. Okay, and I'm going to name it ABCD. And it's a parallelogram, so these ones are parallel and these ones are parallel here. So I'm going to start writing. This is how I'm going to set it out. I'm going to say ABCD is a parallelogram and AB, vector AB, is equal to vector DC, and I'm going to call that little vector there A. And vector BC is equal to vector AD, and we'll call that one B. Okay, so we've got to start by defining what our parallelogram is. Next, we've got to think of what we are required to prove. Okay, and this is a step a lot of you left out, so it didn't really make sense what you were doing. I'm going to write, I'm required to prove, I want to prove that if the diagonals meet at right angles, then the length of AB is equal to the length of BC. That's what it means for it to be a rhombus, for this side here and that side there to be the same length. Okay, now I'm going to make this into mathematical language. What I'm required to prove is that if AC, that's our diagonal, vector AC dot vector BD, or DB, it doesn't actually matter there. If AC dot BD is equal to 0, that means that they meet at right angles, then the magnitude of A, that's AB, the length of AB, is equal to the magnitude of B. Can you see my logic here? I've taken this here and I've turned it into what I'm actually trying to prove. Now let's set up what these vectors are. AC, how do I get from A to C? Well, I'm going to go along A and then along B, a positive direction. What is vector BD? Going from B to D. How am I going to do that? Well, I'm going to go along B in a positive direction, and then I'm going to go minus A, like that. Okay? So I next need to work out AC dot BD, and that's going to equal to the dot product of A plus B dot B minus A, like that. I'm just going to FOIL that out now. A dot B minus A dot A plus B dot B minus A dot B. That one and that one will cancel, and what I've got left with is B dot B minus A dot A. Okay, now you'll remember that if we've got B dot B, that is equal to the magnitude of B all squared, and same with A dot A. So if we've got, let's just change it to that. Okay, now I'm going to use some words. If AC dot BD is equal to 0, then magnitude of B all squared minus magnitude of A all squared is equal to 0. And then magnitude of B squared is equal to the magnitude of A squared, which means magnitude of B is equal to the magnitude of A. Then I'm going to write something here. This means, if in doubt, write it in words, that if the diagonals meet at 90 degrees, I could even write there, AC dot BD equals 0. Then the sides are the same length, and the parallelogram is a rhombus. I've finished. Okay, that's how we do that. So you have to really explain your logic. I had people doing this sort of stuff, but there was no real clue about why they were doing it. It was just a bunch of vector algebra on the page that didn't really make sense. So it's important with proofs that we do the job properly, that we really set out the logic behind what we're doing. We don't be scrappy about it, because there's no marks for a scrappy proof. Okay, I think you need to go through all of that really carefully and then do the diagnostic test all over again.